Um, Hello students. Today I'm going to teach you DBSCAN clustering algorithm. DBSCAN stands for density-based spatial clustering application with noise. This and then clustering algorithm is a density-based clustering algorithm in which we discover the clusters of arbitrary shape and which are stored with some noise. This is very efficient to find out the noise in the data, and it can filter out the noise, and it can divide the data into high density clusters, and the points which are of very low density or lies alone would be considered as the noise. First of all, I want to define you how to decide a region as a dense here. In it, what we do, we decides a minimum point criteria. This is the minimum point number of the neighbors in nearby the certain points within a certain range, which is defined in a circular region of radius epsilon. Here, the radius which is used for defining a region is epsilon. Epsilon is basically the radius of the neighborhood of a point P. Here we draw, taking P as a center, we draw a circle of epsilon radius across P. The point lying in this region are called the epsilon neighborhood of that point. This is represented as capital NP subscript epsilon, where Q in data D is such that distance of PQ is less than epsilon, or in simple word, all the points which are inside a circle drawn P as a center and of radius epsilon radius. So the neighborhood of point P, which lies in a radius of which lie in a circle of radius epsilon, are called the neighbor of point P, and it's represented as NP epsilon. The minimum point criteria is for a point to be dense is called min points. It is a threshold value if a point has more than min points or equal to min points number of neighborhood in epsilon radius around it, epsilon radius circle around it are called as dense region. This is shown in this diagram. Here there are 2 points P and Q. We are drawing an epsilon radius around P, and similarly we are drawing a epsilon radius circle around Q. Here we have decided that the minimum point criteria is equals to 4. It means if there are more than 4 points in a circle of epsilon radius around P or Q, any point P or P, then it would be considered as high density region, otherwise as low density region. So here we are checking after finding, we can easily note down that see that there are 3 points in neighbor of point P. There are 3 points, and there are 2 points in neighbor of point Q, so both are low density regions. So none of them satisfy the criteria, and any of them doesn't have more than 4 or equal to 4 elements, so both are rare areas. In DBSCAN, every point is divided into three parts of 3 kind of points. First, core point, border point, or noise point. The core point is the point which is a center of a dense region, or in epsilon radius neighbor, it has more than min points number of data element. We, or in a simple word, we say that a point is called core point if we draw a circle of radius epsilon around it, then we have more than certain more than a certain threshold values number of data element around it. A border, that's called the core point. Border point is a point which is not a core point, but it is in neighborhood of core point. For example, in a given example figure, min point criteria or threshold value is equals to 5. Here in diagram, the point number 1, if we draw a epsilon radius circle around it, epsilon is some already defined value less than 1, then certain defined value, it could be 1 or more than 1 also, but in the circle here, the epsilon radius circle, we can find out there are 5 points. I mean, it satisfies the min point criteria, so 1 would be considered as core point. But the number, the point number 2, which is having just 3 point in its neighborhood, is a not a satisfy the criteria of core element, because 3 is less than 5, so it is not a core element. But the point close to the point number 2 is a point which has between 1 and 2 as a center, is it has 6 point in its neighborhood, so it is a core point and it lies close to the point number 2. So the point number 2 satisfy the criteria that there is a core point in its neighborhood, so it would be a border point. And the points which is not neither a core point nor a border point is considered as outlier or noise points. Here point number 3 with is not a core point, neither it is having any core point in its neighborhood, so it would be considered as the outlier. The cluster formation in DBSCAN is done in terms of two terms: density reachable and density connected. So first of all, what is density reachable? Density reachable or directly density reachable, a point is directly density reachable from a point P if P is a core point and Q is in P's epsilon neighborhood. I'm repeating it. If it is close, a point is density reachable if it is in epsilon neighborhood of a core point. So here in this diagram, we are finding out that min point criteria is equals to 4 and P is having 4 points in its neighborhood. So P is a core point and Q is not a core point, but Q is is in distance of epsilon to a core point P. So Q is density reachable to point P. But similarly, P is in epsilon distance of point Q, but Q is not core point, so P is not density reachable to Q. I'm repeating that Q is density reachable to P because P is a core point, but P is not density reachable to Q because Q is not a core point. So density reachable is an asymmetric relation. Next, the density reachable conditions can be applied iteratively as shown in this diagram. A point P is density reachable from a point Q if there is a chain of points P1, P2, and P1, P2 up to point Q, like shown in this diagram. Here point P1 is directly density reachable from point Q and P2 is directly density reachable from point P1, and point P is directly density reachable from point P2. There is a chain that connected from a start initializing from a source point Q up to point number P. This way P is connected to Q, which is a core point, via density reachable points, intermediate points P1 and P2. So Q is, but here we can check out that we cannot say that P is density reachable to point Q because P is not a dense region, as we have taken a criteria of min points equals to 7 and P is not a core point. So P P is density reachable to Q, but Q is not density reachable to P. As I have told you that this is a asymmetric relation, and by forming a chain-like structure, we can expand the density reachable region, and this is used to forming this is used for connecting dense region and forming clusters. The next criteria that is used for creating cluster is the density connectivity. Density connectivity, a set of point or pair of point P and Q are density connected if they both of them are not core point, but they are density reachable to a certain point O that is a core point. Here again, 1 point criteria is equals to 7 and O is satisfy the criteria and it is a core point. Point number P and point number Q are density reachable from Q, but they are not, both of them are not core point, but they are connected to a core point via density reachable condition. So here we would say that density connected is used to connect two not 2 points which are not core point along with the help of a core points by using the concept of density reachable. So this is a symmetric relation. Here P is density connected to Q and Q is density connected to P. Here density connectivity is a symmetric relation, but density reachable is not a symmetric condition. These two criteria, density reachable and density connectivity, are used for forming clusters and connecting dense region to each together. The formal description of a cluster is as follows. For a given dataset, first we decide the two parameters, the parameter epsilon, for which will be decided, which will be taken to epsilon, and min points, which will be taken to decide which points are core point, would be considered as core point, and which to decide the criteria of dense region. A cluster C is a subset of D that satisfies two criteria: the maximality and connectivity. Maximality is the criteria that is equivalent to density reachable, and connectivity is the criteria which is equivalent to the density connected. So in simple word, we can say that the point that are close to a dense region dense and are close to dense region, or directly or through a chain of density reachable points, is the create the cluster, or the points which are connected to a connected via core point. So one is direct connection to a core point and another is the indirect connection through a core point. This is the DBSCAN criteria. That's all about if a point is neither a core point nor a border point, then it would be considered as noise. That's all about the cluster criteria.